Hello again, Tom from Every Step Calculus, everystepphysics.com. The greatest programs in the world for your TI-89 titanium calculator. None better. This is an integral, of course, partial fraction. The reason I put must in here is because if any time you're doing an integral and you can factor the denominator, you're into partial fraction, okay? You buy my programs, of course. I send you all the instructions and all the programs, and you put them on your desktop and unzip them. And then I tell you how to put index 8, the letters INDEX here, and the number 8, and the open and close parentheses, which tells the calculator that you want to do a program. And so I show you how to do that. And then that's the main menu. This program is the main menu of my calculus. Everything I've done in calculus is in this main menu. Nice and neat and organized. Let's start here a little bit on it. I'm already at partial fractions because I've done so many of these. And you can see you get down here, let's see, parametric equations, partial derivatives. Here's partial fractions, okay, because on your test you would know that you're supposed to do partial fractions, or whatever the problem is, U substitution or trig substitution, whatever. All these are in here. But here's partial fraction. We click on enter. We're into the program. And now we're going to enter this equation, an integral, into the calculator. Well, you have to press second alpha. Okay, let me do that again. Second, you see where the L is? Second alpha. And then you can put the numbers and time signs and make sure you put everything in here, okay? I've already programmed this into the calculator because sometimes the emulator will mess up these long, when you're putting in long ones like this, you'll get to the end and it'll say, it'll hang the emulator totally up, and I have to go and start over and reload the emulator stuff. So I programmed this beforehand so I can do it quick and maybe save a little space on the video. But you're going to press second alpha. Then you're going to put x squared plus 1, right parentheses, left parentheses, etc., whatever it does here. Make sure you use parentheses in math. That's one of the greatest tools there is in math. You must use it. You must tell everybody what the heck you're doing with math. You can't just flop things in. Like, for instance, the reason I put 4x here instead of 4 times x is because when people search the internet, they put 4x in. So then it might hit this program and come up with it. But in math, you have to put 4 times x. Sometimes it'll work with 4x, but a lot of times it doesn't too, You need to tell everything and of course division signs, and of course parentheses. If you didn't have the parentheses in here, you'd have 1 divided by x cubed, right? Rather than x squared plus 1. So you got to put the parentheses in. Very, very useful and necessary system in mathematics. So here's the problem, and I always show you the problem after you put it in, and you can change it if you want. If you made a mistake or something, I say it's okay. Here I factor the denominator for you because you wouldn't know. If it gave you partial, you wouldn't know how to factor this. I probably could if I thought about it for about a half hour, but I mean, because I work with this crap every day, but you would never be able to factor this like this. But so there's the factor, easily done as the calculator did it for us. Then we set up the partials. Now I'm not going to teach you how to do partial fractions here, but generally you're trying to get a linear equation after you get done with all this. You don't want any denominators in it, okay? So that's the reason you're multiplying the denominator by the same thing. But just write this stuff down on your paper, and then it'll be more clear to you, and it'll be correct, that you really know what you're doing. So this condenses to x squared a, x squared plus, you notice this is linear. It's not, there's no denominators in it, okay? So you have to do that in partial fraction, somehow get that to there. You can do it in your head if you do a million of these problems, like I have, but You're not going to know how to waste time doing this. So now we're trying to find A, B, and C of this. So you figure out, you look at the what I just showed you before, and you look at this, and you put C1, and you say, oh, here, 1 minus 1 will be 0. So I can eliminate B, and I can solve for A, and then if I find A, maybe I can solve for C, etc. like that. So that's what your thinking is. So you put in x equals 1 to cancel the bx plus c term. And that turns out to be A equals 2/5 when you do the math. And then the next step is x equals 0. You do that to eliminate the b, just the b. And that turns out to A, and then you're substituting A for 2/5, which we just found. So when we do that, then in the math, C will come up to 3/5. You notice I even do the calculations because in the 25 years ago when I was in calculus, I needed to quickly do these calculations, make sure they were correct. I would mess up the minus sign or something and get something wrong in the problem somehow. And so C equals 3/5. Now we have an x equals 2. Now it's amazing in this system here that you can put any number. You could put 1,485 in here and it would come up with C equals 3/5. So that's, math is like that. Math is so great, so unbelievably great. Works all over the universe, and really should be worshipped. It really is great, So here we're going to put 2 in for x, and we're going to put 2/5, which we found for A, and C is 3/5, okay? I've chosen 2, just to make the math simple, I guess. So here's the original equation again, partial fraction equation. We're going to substitute the 2 and the 2/5 and the 3/5 for C, etc. here. Write all this exactly as you see it on your paper. Don't mess around with this. Always scribble, because nerds and genius math people always scribble numbers and stuff. They never write clean and nice, or always acting like they can do it in their head in 2 seconds and no big deal, And that reduces to this kind of thing here. I do all the math. Here's where you're figuring it out, doing the calculations to find B, etc. And B is equal to 3/5. So we're ready to do our partials. Our partials are 2/5, 3/5, 3/5 here. Notice we have the x here. That means we can use substitution. This is a totally different memorized integration formula that you have to do that integral there. There's no x, there's just a 1 over an x squared plus 4. So here's the integral set up. Write that on your paper. Let's do the first integral, okay? First integral is just a normal log answer when you have a denominator and nothing in the numerator. It's always a log of x minus what the denominator is, and 2/5. Second integral, you take the constant out of an integral. I always do that. Take the constant out first. Notice we're left with x over x squared plus 4, so that use substitution. I show you how to do that. U equals x squared plus 4, du equals this, du divided by 2 equals x dx. This here has to match the numerator, which it does. You can eliminate that if you match that, okay? So you get rid of that. So we substitute u for all this stuff here, u, and then we back sub, and so we get 3/8 times log of x squared plus 4 plus c. The third integral, take the constant out again so we can look at it and see what we need to do. Here's 1 over x squared. Well, we can't do anything with u substitution, so it's an integration rule. And here's the setup for it. You have to memorize this. This is in your calculus book, of course. 1 over a times arctangent of u over a plus c. Okay, so what is a and what is u? Well, if we can find that out, then we can substitute and we'll have the integral. So I show you how to do a squared is equal to 4, so a is equal to 2. U squared is equal to x squared, so u is equal to x. We substitute that in. The answer is 3/18 times tangent of minus arctangent of x over 2 plus c. So this whole integral here, which we just originally put in, wanted to find, here's the answer. 3/10 arctangent x over 2, etc. Pretty neat, huh? Everystepcalculus.com. Go to my site, buy my programs, and pass calculus. It's as simple as that, or certainly learn enough to pass it. And of course, remember I started my physics program. Some guy from Long Island, 50 years old or so, was taking a physics test, and he asked me if I could program his physics test for him. He paid me $3,000 to do that. So that's how I got into programming for physics, you know. And then of course I programmed my own electronics. I was an electronics major at San Diego State University, and so I programmed everything. Programmed lasers, programmed convex mirrors, concave mirrors, all kinds of things I programmed to help me get through college. And of course I still have them in the calculator. I still can do all these problems right now, and I'm 30 years since then, you know. But you load my programs and use my programs. You can call me. I'll help you with calculus. I'll help you with whatever I can to make you pass calculus, you know. And you know, subscribe to my site if you want to too, and pass this along to your friends or something. So anyways, good luck in your classes, huh? Have a good one.